My name is John Daly, and this is my extra credit problem. Question 3 states, in t seconds, a particle moves s meters in a straight line, where s equals 3t squared minus 2t. The question A asks, find the average velocity between t equals 2 and t equals 3. The equation for average velocity is f of b minus f of a over b minus a. The function f is referring to the equation given to you in the problem. A and b are the variables you use to plug into the equation. B usually represents the larger of the two numbers, as it does in this equation. So you plug 3 where B is, and 2 where A is. T, or in the next step, you plug in b into the function, so you get 3 times 3 squared minus 2 times 3 minus 3 times 2 squared minus 2 times 2 over 3 minus 2. These are the functions. It's SB minus SA, as you had over here, B and A. You do the math here, which will get you 21 from this and 8 from this. And also 3 minus 2, you just carried over. 3 minus 2 is 1, and 21 minus 8 is 13, which gives you 13 over 1, which results in 13. That is how you find the average velocity between 2 points. For B, it says estimate the velocity of the particle Vt at t equals 2 using h equals 0.01. For starters, just like we did in the last equation, use the same formula for the estimation. F of b minus f of a over b minus a. It is important to note that b equals a plus h, which in this equation, a, the only value given, t, equals 2. So you plug in 2 for a, so it's b equals 2, and h, which is 0.1, you plug in to the h value here. So it's a is a 2 and h is the 0.01. So b equals 2 plus 0.01, which equals 2.01. This is your b value for the equation. You plug the b into where it says b, and a into where it says a. Then the next step, after plugging it in to the equation, as you did in equation 1 with SB and SA, you do the same here with B and A. So you take the original equation found here and plug B into it, which gives you 2.01 times 3 squared minus 2 times 2.01 minus what would be SA, which is 2 squared, or 3 times 2 squared minus 2 times 2.01 over 2.01 minus 2. Remember, this is B and this is A. This is B and this is A. This equation equals after doing the math up top, you get 8.1003 minus 8. B and A. B minus A resulted in 0.01. After doing the math here, this obviously will equal 0.1003, and this will just be 0.01. So it's 0.1003 divided by 0.01, which leaves you with the resultant 10.03. That is how you estimate the velocity at a given point. To find the exact velocity at a given point, you must go back to the original stated equation here and find the derivative of it. To find the derivative, the first derivative, you apply the power rule, which is k times px raised to the p minus 1. So essentially what that's saying is the power of x minus 1 and what the power originally was times that by x, and if there is a constant you leave it. But solo constants by themselves without a variable, for instance if it was just 5, that would equal 0 in the first derivative sense. Okay, and now I brought down the original equation, 3t squared minus 2t. There it is down here, 3t squared minus 2t. Apply the power rule, and so that would be minus 2, which would give me 1, which would leave the t, and times the 2, times 3 by the 2. So that would be 6. So it would this would be minus 1. So that would give you 0, which makes t1 and leaves the 2 by itself. This is not considered a solo constant because it originally had a variable with it. So the first derivative of the original equation is 6t minus 2. You then go and plug in the only given variable, which would be 2. So you plug it in, and it's 6 times 2 minus 2, and this equals 10. And that is how you find the exact value, velocity at a given point. Thank you.